Okay, so I'm recording this video to help you get through this short problem set at WebAssign. Okay, and the number one mistake people make in this chapter is for a question like number one. See how these are related? These are related samples. It's an older sibling and a younger sibling. So these are dependent samples. If you look back in the textbook, okay, in chapter 2 for mod 2, let's get this out of the way. Um, this is a pair of different. These are related populations. Okay, so we don't treat them as independent populations. It's matched pairs. So what we're going to do is we're going to find the differences. You're going to work the difference. So this example about cholesterol before and after, the same person after they took the meds, we found the differences and dealt with the differences. If you look at the problem set in the book, do you see how even there mean differences? It's paired data. So this is the matched pairs. And see how this is about IQ scores, just like that WebAssign question is. The differences here, they give you the differences. At WebAssign, they don't. So you have to find those differences. And once you do make those differences, find those differences, then you get a one sample. You do a one sample t-test. And these are always t-tests in this chapter because we don't know the population mean different to the population, right? Because it's different. So we treat this as a t-distribution. And we don't worry too much about the sample size here. I mean, in live studies, it's usually a huge sample, so we don't worry about that. And I'm just more concerned about understanding the difference between the matched pairs and independent samples. Okay, so how do I want to do this? Well, you can see Dr. Stevens' method of this. Maybe what I should do is, do I want to do the WebAssign question? I guess I can. Let me come back here. So see here, they don't give this to me. So you can grab a calculator. Now, do they tell us which way to subtract it? The claim is that the older sibling IQ minus the younger sibling IQ is positive. So HO is mu sub D, the mean difference, is equal to 0. There's no difference between the sibling that times the birth order and IQ, and then the HA is if there is, or H1 is there is a difference. It's a right-tailed test, of course. So in order to do anything with this, so we actually got to find those differences. So I'm going to grab this, I'm going to throw it into a spreadsheet, and I'll be back. I paste those into a spreadsheet, and I'll walk through the formulas for you in case your spreadsheets give you a hard time. So what I'm going to do, I'm going to do equals. That's how you tell a spreadsheet you're doing a formula. And I'm going to click on that 83 minus the younger. I can't quite see it underneath that. And that's the difference. And of course, Google Sheets like to do this autofill thing, which is wonderful in this case. So those are the differences. The older sibling IQ minus the younger sibling IQ. That's what this test has for. Now, because this is a quantitative variable, we're going to have to work with means. And you can certainly paste this data into the Rossmann-Chance applet and do that. When we come to two independent samples, that doesn't work so well. I know I probably have some video out there where I showed that, but recent semesters, it doesn't work so well. So I'm going to show you how to do the mean and the standard deviation in the spreadsheet. And we'll just use those summary statistics to do this calculation with Rossmann-Chance. So to find the mean on a spreadsheet, I'm going to do equals, start typing the word average, and then we're going to take the average of the differences, not each individually. That's treating it like a two-sample t-test. This is a one sample now because we're dealing with the differences. And now I'm going to do the standard deviation, so equals STD, and pops up. And I'm going to find the standard deviation of differences. And I know N is what? 10. There's 10 of them. N is 10. I'll write that right here, even though I don't really need to. Okay, so now let's go run the test. So I'm going to do a new tab. I'm going to go to Rossmann-Chance, and I have this linked in the course in Canvas. And we got one mean because we're just dealing with the differences. Even though it's a two-sample test, it's matched pairs, so we just deal with the differences. So one mean, I'm not going to paste in the data. I had 10 items, 10 pairs. I had a mean of 2.4, and I'm going to copy and paste that one in. A mean of 2.4, let's come over here, 2.4, and I'm going to paste in that standard deviation, calculate it, and I want to test the significance, and it was a right tail test. Notice 0, right? Calculate, and there's my test statistic. There's my degrees of freedom, n minus 1. We don't really need that. And there's the p-value. So if I come to WebAssign, let's see. Nope, that's the teacher side. Here we go. So I know this is the right tail test. The t statistic is what? What was that? 2.01, and it makes sense it's positive because this is a right tail test, right? And then 0.0377, 2.01. Maybe I can slide this over so I can see it. Maybe I can. So 2.01 it was. And then p-value is 0.0377. And now, what level of significance are we testing at? We're testing at the 1% level of significance. Well, this p-value is more than 1%, so we're going to fail to reject HO because it's bigger than the p-value. And we say there's not enough data using Dr. Stevens' verbiage. There's not enough data to support the claim that on average older siblings have a higher IQ than the younger sibling. Okay, so that's when you recognize it's a match pair situation and work with the differences on a one sample t-test. Now we get music and data, and these are two independent samples because there's people that took the SAT that did study music, and then there's people that took the SAT and didn't study music, and we want to test the claim that students who study music in high school have a higher math SAT score than those who do not. So what we got to do is we got to think about what HO and H1 is. I don't think WebAssign asks us to do that. Well, they do have it like this. So there's two ways to write this hypotheses. And if you look at the notes that I provided back in the week, what is this, week 11 outline about using software, even my notes, I'm going to say HO, you can do it the way Dr. Stevens wrote it, where mu sub 1, the people who studied music, minus the people IQ, average IQ of people who do not study music, is just equal to 0. There's no difference in that. The other way to write that is mu1 equals mu2. The averages are the same. Then for HA or H1, they told us down below here that minus mu2 is greater than 0. In this case, we can say mu1 is greater than mu2. The average of people that studied, that's the claim, isn't it? That's what there is. That is, okay? So now to get this to work in that Rossman chance applet, sometimes copy pasting the data just doesn't work these days. So I'm going to show you a different way to do this. I'm going to select all of this table. Control C. I'm going to go to my spreadsheet and I'm going to do a new tab. And I'm going to paste them in. Okay. Now, if you double click and try pasting them in, see how all goes in one cell. So don't do that. Right. That's not all I did was one click. I clicked once on the cell. It just selected and I can paste it in. Okay. Now what we're gonna do is we actually have to find the mean. These aren't matched pairs, these are two independent samples. So they each will have a mean and they'll each have a standard deviation. So I'm gonna do equals average, here it pops up. And I think, is it grabbing it for me? Let's see, let's make sure it did that right. It did, it doesn't matter that it's empty. Then I'm going to do equals standard deviation. Oh, isn't Google Sheets so smart? And that's the standard deviation. Now I'm just going to fill that over. You can type the same thing over here, but you see how it just automatically copied and pasted over. So those are the two means, and we have, let's see, two different sample sizes too. So we're going to make sure, let's see, there are 8 people who studied music, and there are 11 people who did not. So let me see, let's come grab that Rossman Chance applet. I'm gonna break that out to a separate window. Here we go. Now we've got two means. I'm gonna select two means. Notice the way they have it all set up for us. So group one was 8 people. They had a mean of 560.25 and a standard deviation of 35.7841. I'll go with. I don't know. I'm trying to keep my WebAssign happy, so that's always means more decimal places. 41. I'll go with that. And then there's 11 people that did not study music, and their average SAT score is 523. And that standard deviation is 31.5. 087 go with. Now, some people who are confused are going to say, oh, the average of the SAT people is higher than the average of the average of the music people is higher than the average of the no music people. So yeah, music helps. Well, you got to test it to see it's significantly different. That's what the statistical test is. So I'm going to click calculate it because I'm not sure I did that. Let me maximize this. And we did HO is equal, H1 is greater than, we'll calculate it. There's our test statistic, there's our p-value. So 2.35. Let's see, where's WebAssign? Okay. Sometimes this happens. Here it is. What was it? It was heck. It was 2.35, and I got the 2.35. 2.35. It's a right tail test. There's the p-value. And because that p-value, what's the level of significance? What are we testing this at? 5% level of significance. This p-value is less than 5%, less than 0.01 or less than 0.02, less than 0.05. So we're going to reject HO. So the data supports the claim that students who study music in high school have a higher SAT score. Okay. And that was HO or H1, right? So now we come down to this boomerang generation. Here, let me maximize this. And you see how they don't tell us any standard deviation? Well, they tell us the standard error, but when we do that, if we do the formula, we don't want to do that. So I'm going to write down those numbers here. So I guess go to another screen. Where are they? So I'm going to write down, let's see, for back in 2012, remember we wrote this book in 2014, so some of these are getting dated. So there are 194 out of 808 people that they studied. And in 2000, back in 2000, there were 288 over 1814. So one thing that was big in our minds still in 2014, or even in 2012, I guess, was that economic crash that happened in 2008. Some of you might remember that. It was a big deal. A lot of people were hurting. So that's why people moved. The boomerang generation couldn't handle it on their own because they either couldn't find a job or, they just weren't earning enough money. So that's why this is a big deal then. So they give you the formula for the test statistic, but because this is a 2 proportion test differences, right? We can go use Rossman Chance and get a lot of this. Now, something they didn't ask us with this question is they didn't ask us to write HO and H1. So maybe I should do that before I go too much further. Back here. So the claim is what? The claim is has to claim that there's a greater proportion of young adults who moved back with their parents in 2012 than there were in 2000. So HO, the proportion of people who moved back with their parents, I'm going to write it this way. In 2000, is the same as the proportion of people who moved back with their parents in 2012. And then H1, oh, looks like I'm doing this backwards. See, they want this, they want, just keep WebAssign happy. They want me to reverse this. So we're going to switch this up. So this will be 2012 and 2000. And then H1 will be P of 2012 is greater than the proportion back in 2000. That's the claim, okay? And again, you can always do you can say the P minus the P equals 0, and P minus P is greater than 0. And that's actually, I think that's how the WebAssign, which this is 12 and 20, and this is 12 and 20. 12 and 0, 0, I guess I should write. Okay, now we're going to go run that. We're going to run a 2 proportion z-test. Pop this up. I got to minimize this, I guess. And I got to come here, and I'm going to erase that writing so that I can see something. So I'm going to switch this to actually maximize this because I've got the numbers written down. 2 proportions. They're going to look, so back in 2012 is group 1, right? So there were 808 people, and 194 of them had moved back home. And back in 2012, there were 1814 people, and 288 of them moved back home. And we'll calculate it. We are saying that 2012 is greater than 2018, so it is a right tail test. And we'll calculate it. There's our test statistic. There's our p-value, which is 0. We knew it. It's more than 3 standard deviations above the mean, so it'll definitely be a really low p-value. So 4.96. Let's go back to WebAssign here so we can get this right. Okay, so the test statistic is the, what, 4 point, I think I copied it. Oh, they're asking us to do the critical value of Z. So I believe what we're going to do with this, oh, this is different. Well, let's see if I get it right. So let me open up the T table. Okay, so I opened up the z-scores table. I'm sharing my screen. Yep. So we're testing this at the 1% level of significance. So if I go look at, just a minute here. If I go look at the T table here, come back and share my screen again. Hopefully I don't have to stop this anymore. Share screen, share. Okay, so down here you see how we've got this critical value T at 1% level of significance on a right-tailed test. Our critical value of Z is 2.33. That's the cutoff of the rejection region. Now, if we come back and if I can find the Rossman chance output, actually I already typed that in. So there's the Z score that came from the test statistic. When I just say 2.33 is a critical value, since the Z score falls out past the critical value, we're going to reject HO. We can also say this because the p-value is 0, right? If that p-value is practically 0, if I could scroll over and look at it, it would be better. We're going to reject HO. It looks like the data supports claim that a greater proportion of all young adults move back home. Okay, and that's that. Let's see if I do. I think I've got everything. Do I get answers and everything? Let's see how I do. It's been a while since I've done this assignment. Submit for testing. No, it got I got all 14 points. Good. All right, so that's telling them. I'm going to warn you right now, the biggest problem with the last exam is somebody tries to treat one of these match pairs situations as two independent samples, and they get it wrong because they ran the wrong test. You got to make sure you run those condition checks. Okay, those requirements that Dr. Stephen talks about in the book. Okay, so hopefully this helps you complete this assignment. Get some work practice out of the textbook too. It's the best thing you can do for yourself.